Hello, my dear students. Today I'm going to take one more example on that on demand that NCRT example. Just NCRT the example. You can observe this one. So if you'll observe this, the position of the particle. What is the NCRT example? They want velocity, acceleration, and magnitude of direction at t equals 3 seconds. Direction for velocity also, but at t equals 3 seconds. So original position vector is given in a form ijk as usual 3 for t I bar I hat 2 t square j hat and 5 k hat that. So let's begin. So first, if you'll observe, what is our first part? That is related to our this velocity as usual. So if you'll observe this one, just I'll go back here. First, v of t is equal to the vector dr by dt here. This is a vector dr by dt, and we'll be taking the derivative as usual to get the velocity for this. So if you take the derivative, it will be d by dt of the given position vector 3t I hat plus 2t square j hat actually, and plus 5k hat. So let's take the derivative. Now 3.0, it is not 30, it is 3.0. If you'll observe that, that is 3.0. I will go on pen for a second. Just a minute. Remember, so it is 3.0, point is over here. So that will happen, that will get converted this t. This t is going to become 1. So the derivative will be 3 I hat plus 2t square. T square that will be 2 times. No, just I'm writing over here. 2 times 2t, that is into j hat, like that. The derivative of t square is 2t multiplied by 2t, that will be j hat. So 3 I bar, you can say I hat plus 4t bar. This is what you got for the velocity. This is what velocity we are getting. Now let's question is that what is acceleration? So acceleration part is that a will be equal to dv by dt. So that is the velocity derivative, differentiation of the velocity dv bar upon dt. So we'll differentiate this velocity part, what we got over here. So if we'll consider after differentiating, we are getting 4j. Why 4.0 j hat? Now this part, remember this what is happening over here. Just get an idea. This part is a constant. This is constant. So it is becoming zero. This will become zero. And here we are having the part t. So this t is going to become 1. So differentiation of t will be 1 over here. So as a result, you will be getting 4j hat. So 4j hat will be your differentiation part. Okay. Now let's go for the condition. What is the condition? They are going t equals 3 seconds. So at t equals 3 seconds, what will be t equals 3 seconds? For the velocity, find the magnetic area v of t. Now, we will consider this equation v of 3 seconds. Already there is no t here. So this 3 is going to remain as it is. And here we'll be getting 4 at 3 t seconds. One more time I'm writing there. This there is no change with I because there is no t. This is becoming 12. How I got this 12? Can you guess? It is here part is there 4t. So 4t is equal to 4 times 3. That will be 12 only. So I'm substituting the value 3 seconds for this, and I'm getting a velocity at 3 seconds 3I plus 12j. Now let's go for acceleration. Now acceleration already we are getting 4j. So this is the final answer what we are having. Now we want magnitude here. What is the magnitude here? Under root 3 square plus 12 square. So that will be 12.4 meter per second. And that is the velocity for the magnitude. And finally, if you'll consider the direction, direction is given by tan inverse of v of y upon v of x. This is the formula we are having. Tan inverse of v of y. We'll be taking the ratio for the y component of velocity divided by x component. So that is equal to, so what we'll be having, if we'll substitute this value, that is tan inverse of 12 upon 3. So that is nothing but it is 76 degrees. So tan inverse of 4. So 4, that will be considering radians there. So that will be 76. Approximately we are getting 76 degrees there. Okay. Okay. Thank you.